APIT welcomes you to the world of parboiling. Here, APIT, Agri-Process Innovations Technology, a Indo-US joint collaboration presents the world's best paddy process specialist, APIT, that has a unique concept of parboiling system. Thanks to APIT for its innovative parboiling system, which can produce high quality of parboiled rice based on the global consumer preferences. APIT parboiling system ensures best rice in terms of its quality parameters and nutritional aspects. APIT also ensures proper hygiene process, nutritional preservation, environment-friendly methodologies. APIT parboiling system can produce all the 6 colors of parboiled rice based on demographical demands like super white, white, cream, pale yellow, amber yellow, golden yellow. APIT's parboiling system has a scientifically process-based infrastructure. The process will be carried out in 3 phases. 3 phases of parboiling system includes pre-hydration system, also known as pre-steaming. Hydration is also known as soaking. Gel cook, also familiar as final steaming. Our complete parboiling process is driven by pre-designed process values from the world's first parboiling process design software, PROSE. Thanks to PROSE process design software for having more than 5,000 process design data which can be applicable for most of the global varieties of rice. Our PROSE software is designed on the basis of 4 crucial parameters of grain. We call them as GMAD, gelatinization temperature of processed grain, moisture of the grain at processing point, age of the paddy at processing point, average density of the raw material in machine. Time, temperature and pressure in the heat load depend on moisture, age and density of the paddy. The operation of the parboiling system starts with the feeding elevator. The feeding elevator carries the completely cleaned raw paddy to the chain conveyor, which transports the paddy to the surge bin. At the end of the conveyor, the buckets are emptied by gravity into the discharge section. The APIT feeding elevator is designed for its higher efficiency of bulk material handling and is updated with the latest technologies like speed monitor, belt slack monitor, energy meter, information receiving and sending station. Feeding elevator transfers the paddy to the chain conveyor. APIT chain conveyors are best performing machines which receives raw paddy from feeding elevators and distributes the paddy to multiple numbers of surge bins. Feeding elevators and chain conveyors are built with the latest technology like chain conveyor distribution mechanism having pneumatic slide gates with manual override. Surge bins are fabricated for sufficient amount of storage of raw paddy. Our entire surge bins are equipped with level monitoring sensors. These sensors stop the filling when it reaches a definite maximum level, and then the paddy is fed to the PHS tank. Here is the first phase of parboiling infrastructure, scientifically known as pre-hydration process. APIT's pre-hydration machine is having a cylindrical top with conical bottom and scientifically designed steam spurger system which takes care of treating each and every grain properly. The running capacity of the PHS machine is multi-times the holding capacity of the hydration tank. After filling of the paddy, heat load via steam is enforced with a low-medium pressure through the branched spurger system. After filling up the paddy in the PHS machine, first volume of the paddy will be given thermal treatment. This thermal treatment is completely dependent upon 3 parameters: latent heat, sensible temperature, time of thermal treatment. Thermal treatment mainly ensures uniformly distributed heat load to every grain. Pre-hydration process of the paddy results in filling up of cracks and fissures in paddy, increases the porosity of the husk, resulting in increasing the absorption rate of water that helps to reduce soaking time or hydration time. When thermal treatment coefficient reaches equilibrium, then the rotary discharge valves start to open. From that point, the entire process will be carried on the basis of first come, first treat and first out. APIT paddy hydration can be carried out by two ways: paddy first process, water first process. In most of the cases, generally paddy first process will be carried out. APIT hydration or soaking infrastructure consists of auto hydro feeding mechanism, auto hydro circulation mechanism, auto static hydrothermal temperature maintaining system, auto hydro draining system, discharge mechanism, auto or manual. The hydration process is a very important process in parboiling. In this process, the grain has to achieve maximum gelatization. In gelatization, deformation of starch granules occurs. APIT ensures that each and every grain will undergo uniform gelatization process in order to get a desired result in terms of color and hardness. Hydration process. Hydration process is carried out in several steps: dwell or thermal seasoning, water feeding, water circulation, drain, discharge, dwell or thermal seasoning. After the PHS process, there is a process called dwell or thermal seasoning. After thermal treatment at PHS, the hydration tank receives the paddy. After coming to the hydration tank, the paddy will be conditioned or thermally seasoned for the prescribed time based on the consumer color preference. Dwell or thermal seasoning is done for base color application, and that is mainly dependent on the age of the paddy. APIT has auto water feeding mechanisms. The required quantum of water will be fed into the hydration tank and it will be monitored, regulated and controlled by PLC. Before water feeding, APIT Pro system will decide the temperature of the feeding water based on the following parameters: consumer color preferences or process color acquisition, GT, age, moisture, and possible process color acquisition. Temperature of the soaking water plays a very critical role in the hydration or soaking time. To ensure uniform gelatization, APIT has designed the most effective aqua circulation system. Circulation system has two components: total number of circulations per cycle, circulation pitch. Once the paddy reaches the saturation in water intake, then the hydration process will be concluded. At the end of the hydration, we obtain gelatized paddy. During the process of gelatization, starch granules get deformed, and due to which the grains swell by approximately 14 to 18% and the nutrients are diffused from the bran to the endosperm. After this process, surplus water will be drained with our ADS or auto drain system with the help of our to-be patented QAD valves. After hydration, the moisture content of the discharged paddy kernel will increase up to 28% to 30% approximately. Then after that, the gelatinized paddy is discharged to the belt conveyor and it is taken to the next valve chain of the parboiling ecosystem. Completely gelatinized paddy will discharge to the belt conveyor, which in turn feeds to the elevator of the next level process. The next level process, we call it as gel cook. Cooking of gelatinized paddy is termed as gel cook. APIT's gel cook station, known as Bhata Gel Cook Station, is a fitting tribute to one of the great grain scientists of India, Dr. K.R. Bhattacharya. Dr. K.R.B. is a true inspiration to APIT's innovation and implementation. APIT Gel Cook Station assists to achieve the best degree of starch gelatization, uniform gel consistency, which ensures homogeneous parboiling results in best characteristics of color, texture, gel consistency, shelf life, and other best qualities of milled rice. Surge bin feeds the gelatinized paddy to the gel cook. Once the paddy is filled up to the holding capacity, pneumatic slide gates will close and heat load in the form of latent heat of steam will be given to wet gelatinized paddy. The uniform heat load spreads across all the zones. Gel Cook Station is a unique concept that consists of 3 alternate dynamic thermal treatment stations and dynamic seasoning stations. These stations have a unique geometrical shape arranged vertically with increasing intensity of heat load to give the best quality parboiled rice. The intensity of the heat load is directly proportional to the amount of sensible heat load in each zone, which further depends on the size of the heat load distributor pipes. The most important aspects of Gel Cook are to be patented branched spurger system. Each dynamic thermal treatment zone has branched steam distribution spurger system which provides effective distribution of heat load to each and every grain. In the gel cook process, nutrients are pressed into deformed starch granules. Calcium, thiamine, folate, niacin, iron, sodium, potassium, calcium, magnesium, phosphorus, dietary fiber and carbohydrates are completely locked into the endosperm. After that, the structure of the starch gets reformed and the grain becomes harder. Hardness of the grain is controlled by varying the DSG or degree of starch gelatization. Paddy is discharged from the high intensity zone when desired DSG or degree of starch gelatization is reached. The discharge is done through the rotary discharge gates.